Here we go with Unit 2.4. How do I factor special quadratic? So before we head into that, let's do a very quick review on how do I multiply these things. G minus 5 and G plus 5. You guys know I love the box method. And remember, it doesn't matter where the plus 5 or where you put the minus 5. Same thing. G times G is G squared minus 5G. Just fill in each boxes. This becomes a negative 25, okay? Combining my like terms, this is from Algebra 1. This actually becomes G squared. Minus 5G plus 5G cancels off, minus 25. Okay, really quick review, guys. Pause the video, try number 2 on your own. 2x minus 3 and 2x plus 3. Take a minute, pause the video, just don't copy me. Pause the video. You should get 4x squared minus 9. If you did, excellent. If not, you better make sure you understand what you did wrong. So, factoring. Miss Samuel likes to find her A, her B, and her C. This is 1, B is 0, there's no B term, and negative 16. X method, negative 16 on top, A times C, 0 at the bottom. So I want to know two numbers. Remember the trick what I told you? When 0 is at the bottom is always going to be two numbers. Same numbers, one's positive, one's negative. So in this case, 16, I know 4 times 4 is 16, and just one of those will be negative. Writing it out in factor form is B plus 4 and B minus 4. That's it. You can do this on your own. Pause it, do the second one, show me what you know. This is 4y squared minus 9. You should get y minus 6 and y plus 6. This is actually what is one of our special kind of quadratic, which is known as the difference of square. Difference of square is when I have the first number square and the second number square, or I can take the square root of the number and get a whole number. There's no b term. It will always be a plus b, a minus b. And here's a simple proof. You don't need to know this per se now, but this is just a proof to show you that this always works. When I FOIL it out, it will always give me that, and it will always work. Okay? So let's see how this works. What I like to do is take the square root of that. Remember, I have to get a whole number, and I like to rewrite it. V squared minus 9 squared. Then I know it's always going to be V minus 9 and V plus 9. See, I did this in less than 30 seconds. Same goes for this. The first thing you got to do is take the square root of those numbers. This becomes 6 squared. I like to write it back so I see what I'm dealing with. Notice they're all squared, no b term. Yep, I can do this. 6k minus 11 and 6k plus 11. It doesn't matter if you put the plus first and then the minus. Doesn't make a difference. That's it. Look at that. Under a minute, solve 2 problems. But let's see how this works now. Again, it's a simple review. G minus 5 squared. Remember, this is the same as G minus 5 times G minus 5. And I like my box method. I will do this. G minus 5 and G minus 5. Let's go ahead and fill this in. G squared minus 5G minus 5G, but this is a positive. Negative times a negative is a positive. Combining my like terms right here that I outlined in yellow, I will get G squared minus 10G plus 25. Final answer. Now I know all of you know how to do this. Why are we doing this, Ms. Samru? Well, since you know how to do it, pause it, do number 2, which is, you got a little sneak peek, 2x plus 3 squared. Great. Were you able to get 4x squared plus 12x plus 9? I hope so. If you didn't, just pause the video, raise your hand, and I'll come in and see what misconception we had, okay? Now, let's look at the factoring one at the bottom. I like to write this out as A equals 1, B equals negative 8, C equals positive 16. X method, 1 times 16 is 16, negative 8 at the bottom. Two numbers, when I multiply it, I get positive 16, but I add it, I get negative 8, yep, negative 4 and negative 4. So when I want to write this now, I'm going to write B minus 4 and b minus 4. But look at this, b minus 4 times b minus 4. Does that give you a hint up here? Because we're 11th graders, we're going to write this as b minus 4 square. This is our third year of math. We can do this. I know you can. That's going to be my final answer. Okay? Now pause it and see if you can get the second one completed, which is 4w plus 12w plus 9. Be careful, now I'm dealing with w's, okay? Were you able to get w plus 6 square? Excellent. Now let's move on. These are another type of special quadratic that's known as perfect square trinomials. So I have an a and a b term, okay? See, this is my middle term. I don't care about that. But my a and my b term, I can take the square root of it. And when I multiply these numbers and times it by 2, I'll get my middle term. One thing that's the only difference here is that we need to pay attention to what sign is next to my middle term. Here it's a plus, meaning I'm going to bring the plus sign down. It's a negative, I'll bring the negative sign down. Okay? Let's see how this works. So, I need to take the square root of this number. So I'm going to rewrite it. This is actually x squared plus 20 plus 20x. Sorry, 10 squared. What I like to do is my a is 1 here, and it's 10 here. Okay, remember that's my a and my b in this sense. So I multiply these two. I say 1 times 10 is 10, and then I times this by 2. Why do I times it by 2? Look at my formula. It says a squared plus 2ab, meaning whatever a and b is, I need to multiply by 2 to get this middle number here. So when I times 10 times 2, I get 20. Look at this. It's my middle number here, so I know this is going to work. So when this works, what we're going to do is write x and 10. Remember, this is 1x. If it was a number in front of there, we'll see an example like that. And I know it's going to be something squared. This has to be a plus or minus. How do I know what to put? What's in front of that 20? It's an addition, so I put addition sign. That's it. You can do your a equals b equals c equal. It's fine, but it's just going to be longer. Now let's look at this example. Take the square root of both of these numbers. This becomes 5 squared x squared minus 60x plus 6 squared. So in this case, my a is 5 and then this other term is 6. So I check it. 5 times 6 is 30. Then I need to multiply by 2, and 30 times 2 is 60. Check. Okay? If it doesn't equal to this number in the middle here, I cannot use this. Okay? Once I have this, I know it's 5x and 6. 6 is from here, 5x is from here. And I know it's going to be something square. Now, what sign goes here? Basically, you're trying to see what number is in front of this 60. It's a minus, so then that's what comes there. Okay, these are just all shortcuts. You can do the A, the B, and the C again. It doesn't matter. Now, factor completely. This is what you'll see on the regions. Looking at this example, I can see that they all have a 2 in common. Let's take that 2 out. This becomes 16p squared plus 8p plus 1. Okay? How do I know they have a 2 in common? Because they're all even numbers. Good. So this I can rewrite as 4 squared p squared plus 8p, and square root of 1, I can write it as 1 squared. It doesn't really matter. Then I'm going to check. This is 4. This is 1. It has a middle term. So let's see. 4 times 1 is 4. And if I multiply by 2, I get 8, which is what I'm looking for. So now our final step is just to take this 2. And I know this is going to be 4p. And this is going to be 1 square. Now, this is actually a 1. Let's make sure that's clear. What sign goes in the middle here? Look at what sign is in front of the 8. Addition, so that means I keep it as addition. Perfect. Now, let's look at this. What do they have in common? I see they have an r in common. They also have a 3 in common, yes. So when I take a r, 3r out of this, I'm left with 4r squared minus 25. Good. This can be rewritten as 3r. This is 2 squared, and this is r squared, 5 squared. All I did was take the square root of these numbers. But notice, there's no b term here, okay? There's no middle term, but this is actually what we talked about first part of our lesson. This is your difference of square, so I know this is going to be 3r, and I know it's going to be 2r plus 5, and it's going to be 2r minus 5. If you're not sure, look at your difference of square formula again. And here you go, that's it. Now moving on to example 7. Here, I want to solve this. Now take the square root of this, and here is p squared minus 30p square root of that. Check it in your calculator, double check me that I'm correct. 15 squared. So I'm going to write, this is 1, this is actually 15. 1 times 15 is 15, and if I times this by 2 I get 30, which is what I need. Remember, I'm just doing this to make sure I can apply my perfect square formula here. Without, if this 30 wasn't there, I can't do it. So now that I have this, I know it's going to be p, and it's going to be 15 square outside. What sign goes here? What's next to the 30? Great. So that means subtraction goes there. That's my answer. Check. Moving straight along to example 8. Solve and sketch this. But before I solve and sketch this, whenever you solve quadratic, you know it has to be ax squared plus bx plus c equals 0. So let's make this right here into that form. This is actually 4x squared minus 28x plus 49 equals 0. Again, let's test if any one of our things is going to work. Square root of both sides. This becomes 2 squared x squared minus 28x plus 7 squared equals 0. Now, let's check this out. This is 2. This is 7. 7 times 2 is 14, and if I multiply that by 2, I get 28. So I know that my perfect squares are going to work. 2, I know my first term will be a 2x, and my last term will be a 7. That's coming from here and here, square. Now what sign goes in the middle here? Minus. Why? Because it's minus next to my 28. Now this is what it looks like. Now when I want to sketch this, you have two choices. You plug this in the calculator, or just by looking at this. To plug it in the calculator, go to your graph and enter this in f of x. You should have a graph that looks something like this. This is just a sketch of what your graph should look like. So if you don't have this, just pause the video, put your hand up, and ask myself or Miss Ewing how to enter this on your calculator, okay? Now our last example, say find the zeros and sketch it. So zeros is the same thing as solving it, okay? So I want to make x squared minus 64 equal to 0. I know 64 is a perfect square, so this is actually x squared minus 8 squared equal to 0. Remember this from this is a difference of square. So this is actually x plus 8, x minus 8 equals to 0. Again, you can do the ABC method. That's perfectly fine. Remember we talked about this. Branch this off. X plus 8 equals to 0, or x minus 8 is equal to 0. Add 8 on this side. I have x is equal to positive 8. Here I'm going to minus 8 on both sides. This is cancel. X is equal to minus 8. So when I'm graphing this or sketching it, it doesn't have to be 100% accurate. Let's say this is my minus 8. This is my positive 8. I know that my parabola will be passing through at this point. So I know that it's going to be passing through minus 8 and positive 8. These are what's my roots. This is where the graph intersect this is my x-axis and this is my y-axis. So when I sketch that and I find the zeros is just where the graph intersects x-axis. Okay? So what you're going to do, guys, is move on to portfolio 2.4. Look at your formulas. That will help you a lot, okay? I know it's been a lot. Take a break. Take a 5 minutes and then check in with me after. Righty? Good luck!